Lesson 1-5, measuring line segments. This is for geometry. First thing we're going to go over is the length of a line segment, so your distance. To find the distance between 2 points, it's the absolute value of a minus b. There's also another distance formula that we will also go over later on when we're dealing with ordered pairs. But finding the distance between 2 points on a line segment, we would use the absolute value of a minus b. So this right here, to find the length of AB, so if I wanted to find how long AB was, it'd be the absolute value of -3 minus 9. Well, what is -3 minus 9? -12. So the length of that line segment is going to be 12 units. Okay, so that's how you do the length of just a line segment. Now, we're getting down to the 2-column proofs. And what we want to do is we want to find the length of each piece. Okay, we want to figure out how long this piece is and how long this piece is. First thing we have to do is solve for x. So we do this in a 2-column proof format. Okay, all of geometry is proving. So this is going to be a 2-column proof format. So we got this piece plus this piece is going to equal that whole entire piece. And if you see over here, they give us the length of that whole entire piece. So first thing we need to write down in our 2-column proof is the main statement. That's what we want to write down. So my main statement in my 2-column proof is going to be ds plus st is going to equal that whole dt. This piece plus that piece equals the whole piece. This is called the segment addition postulate. Okay? That has to be there. This is a key, very first statement that we need to have. From there, we substitute in. Well, what does ds equal? Well, it equals 2x minus 8. What does st equal? 3x minus 12. The whole length of dt is 60. And what did I just do? Substitution property. Combine like terms. 5x, because now we're just doing basic algebra, minus 20 equals 60. We combined like terms. Next, addition property of equality. So you're going to add your 20 over. So we have 5x equals 80. There's your addition property of equality. Now division property of equality. So x is going to equal 16. There is your division property of equality. Well, now that you know what x is, can we now find these lengths? Well, yeah, we just plug it in. So you'd have ds equals 2 times 16 minus 8. 32 minus 8, which is 24. So ds is going to be 24 units. Can we now find st? Yeah, same thing. Let's plug in the 16. So it'd be 3 times 16 minus 12. So it'd be 48 minus 12, which is going to be what? What's 48 minus 12? 36. Well, if you look, 36 plus 24 gets you to 60, doesn't it? And that's all that's to it. Very, very simple 2-column proof. But I need, again, this initial statement. I need the letters, the variables, the links, the assigned links of each piece of line segment. I have to have that first, stating we're dealing with the segment addition postulate. Okay, one more, and that's the midpoint postulate. So now we've got another line segment here. We've got your midpoint. And normally it'll note, you can see that that's going to be directly in the middle, which is the midpoint. So we got this piece to this piece. So again, when we are doing this 2-column proof, we need that very first statement with the variables in there, or with the assigned points on that line segment. So I would state that AC has to be congruent to BC. Why? Midpoint postulate. Okay, again, that's when they're directly dead in the center. Again, very first statement, that needs to be in there. Obviously, this piece is going to be equal to that piece because they are going to be congruent. They're going to be equal. Now substitute in. So we have 2x plus 1 equals 3x minus 4. There's your substitution. Okay, I'm going to subtract my 2x over. 1 equals, whoops, I'm subtracting 2x over there. 1 equals x minus 4. I did the subtraction property of equality, but I also combined like terms. Okay? One final step, add 4. So 5 equals x. We did the adpo. Now I can figure out what each piece is. Plug it back in. So AC is going to be 2 times 5 plus 1, which is 11. And then I can also find BC. 3 times 5 minus 4, that also had better be 11 because it's midpoint. And that's how you check to make sure you actually did right or correct on your algebra within that proof. But again, I can't reiterate this enough. We need those first initial statements on both of these 2-column proofs. Okay? And again, my proofs are worth 4 points. So if you missed this and just went right to that, you'd only get a 4 out of 5. Okay, so make sure we get that first initial statement in there. So there it is, geometry, lesson 1-5, measuring segments.